So just a quick review of the similarity theorems. First off, we have angle-angle, where you have two angle pairs congruent. That's one way to prove triangle similar. Side-side-side is where you have three side pairs that are in proportion. Another way to prove them similar. And proportion just means you divide them all, like the same triangle over the same triangle, and you get the same number each time. And then finally, there's side-angle-side, where you have two pairs of sides in proportion, and you have the included angle, the one in between, congruent. So the directions here say to use congruent angles to match up the corresponding sides. So what that means is if I look at this triangle right here, we have this x, and this x goes between the two arced angle and the one without anything on it. So I'm just going to label that in red. And color coding actually is very helpful here. And then if you look down at the bottom triangle, the side between the two arcs and the no arcs, so here's the two arcs, here's the no arcs, the side between that is right here, LK, the 15. And if we go back to the top triangle, we look at 20. That's between the two arcs and the one arc. Well, up here, and I'm not just kidding, that's side JK. Ha! What a great joke. Sorry, guys, that was horrible. So yeah, we can use this to create a proportion and solve for x. So you start off with x over 15. I did the red sides first. Doesn't matter which ones you do first, but I chose the red ones. Equals 20 over 25. So then all you have to do now is cross multiply. So we have 25 times x is 25x. And then we have 15 times 20, which is 300. And then finally, all you have to do is divide by 25. How many quarters are in $3? X equals 12. And there you go. So the next problem, we'll do the same thing. But first, one thing we should do is notice that there's only one angle that's labeled congruent. But don't forget about these vertical angles. So I'm going to label those with one arc. So there we go. We have the vertical angles labeled. So now let's label these again. I'll start with the x again, because why not? And the x goes between the one arc and the two arc, just like 6 does right here. And then in blue, I'll label this 15, which goes between the one arc and the no arc, which matches up with the 10. So now, just because I don't want you to think I'm playing favorites here, I'm going to put the blue ones first, and I'll do 15 over 10. Notice that I'm staying like top triangle on top, bottom triangle on the bottom, equals, and then top triangle's x for the red, bottom triangle 6. So all we have to do now, again, cross multiply. 10 times x is 10x. 15 times 6 is 90. Divide by 10, and we get x equals 9. Good way to check your work on these, by the way, is if you look at this, here, first off, x equals 9, and then over here, x equals 12. A good way to check your work on this and make sure you did it right is if you look at these two sides here, we have 6 and 10. See how 10 gets bigger, goes to 15? So 6 should get bigger when it goes to 9. So it's just a really quick, easy way to check it. And like same thing here. 15 and 25. 25 gets smaller as it goes to 20, so 15 also has to get smaller. And it does. It goes to 12.